Hey, welcome back to your favorite intermediate algebra class. Today we're going to talk about identity and inverse matrices. So we're going to find and use inverse matrices to solve some systems here. Okay. So first of all, an identity. So if you think back to your multiplicative identity, when we were working with multiplication, we're looking for, if I take 3 and my operation is multiplication, what's my identity that gives me back 3? And you say, well, 1. 1 is your identity in multiplication, your multiplicative identity. Okay, well, you have in matrices, you have an identity matrix. So it's kind of like the equivalent of 1. So if I have a matrix A times the identity matrix, that should spit out matrix A again. Okay, well, the identity matrix is, if for a 2 by 2, it has 1s on the main diagonal. That's your main diagonal. So 1, 0, 0, 1 is your identity matrix for a 2 by 2. Okay, so 1s are on the main diagonal, 0s are elsewhere. Okay, so this is your identity matrix. Now, you also have inverse matrix, okay, which comes in very handy when you're solving with matrices. So the inverse, if you want to think about multiplication again, let's take 3, and you say 3 times, what's the multiplicative inverse, question mark, so that it gives me the identity back, right? Kind of like the equivalent of 1. You say, well, it's 3 to the negative 1, the inverse of 3, the multiplicative inverse. In other words, 1 over 3 to the 1, which is 1, 3/3, which is 1. Okay, so that's the inverse, multiplicative inverse of 3. So we have an inverse matrix. A inverse, so that if you have any matrix A in a 2 by 2 matrix, okay, A inverse is 1 over the determinant of A times D negative B negative C A. Okay, so let's go ahead and find the inverse down here for this um, matrix A. So this is matrix A. This is like our A, B, C, D right there. Okay, well, according to our formula there, A inverse is 1 over the determinant of A, so like the determinant of A, B, C, D, right, times D negative B negative C, A, times that matrix, okay? So 1 over the determinant. So let's find the determinant. 2 times negative 1, negative 2, minus, and then we got to go this way, negative 5 times 1, which is negative 5. So 1 over negative 2 plus 5, 1 over 3. Now we're going to multiply by D negative B negative C A. So let me go back to this here. Remember, this is A, B, C, D. Okay, D goes first, so negative 1. Negative B, so negative, there's our B right there, 1. Negative C, here's our C, which is negative 5. And then finally A, which is just 2. Okay, so I got negative 1, 5, and 2. Okay, now we're just back to the old scalar multiplication. So we just multiply the 1/3 times each of those. So I got 1/3 times the negative 1, so negative 1/3, 1/3 times that negative 1, negative 1/3, 1/3 times the 5, 5/3, and 1/3 times the 2, 2/3. Okay, that is A inverse. Okay, so this is saying, now that we found A inverse, is saying if I took, the A inverse or the A times A inverse, I should end up with the identity matrix. Okay, so our original A was 2, 1, negative 5, negative 1, 2, 1, negative 5, negative 1. And if I was to multiply that by my A inverse, negative 1/3, negative 1/3, 5/3, 2/3, and I was to go through this process, you remember this stuff, right, from last time. Anyways, what it spit out is 1001. Okay, it's kind of like 3 times 1/3 gives me 1, right? Okay, remember 1 the equivalent of 1, if you will, is like 1, 0, 0, 1 for a 2 by 2 matrix. Okay? So that's what's saying. That's how you find an inverse. Okay, so what if we are given this matrix equation? Matrix A, so here's our matrix A, times matrix X equals matrix B for a 2 by 2. Well, if you're given a matrix A, matrix X, given a matrix B, okay, how would I solve for this matrix X if I don't know that? Well, it's kind of like the old, how would you solve 3x equals 6, we'll say. You say, well, you know what, let me do it. Let me do this one. 2/3 x equals 6. Well, I'd multiply by the reciprocal or the multiplicative inverse of 2/3, so 3/2 both sides, right? When I do that, and then I'd have 1x equals 18 over 2, which is 9. Okay, well, it's the same idea with matrices. We're going to multiply by the inverse. So we're going to go A, let me do a different color, A inverse AX. And if I multiply the left-hand side by A inverse, I got to multiply the right-hand side by A inverse. And order matters here. I'm multiplying. The left-hand side is where my A inverse goes. And you say, well, what is A inverse A? Well, that's 1, 0, 0, 1. Well, what's 1, 0, 0, 1? It's just like 1. So that's going to be your answer. So I just got to figure out A inverse and then multiply it by B. Okay? So step 1, note if you got this, I'm going to have to go A inverse both sides. So X is A inverse B. Okay, so step 1, what's A inverse? You say, well, it's 1 over the determinant of A, D negative B negative C A. And the determinant is 5 times -1, so -5 minus, now we go this other way, -4 times 1, -4. So it looks like it's -5 plus 4 on the bottom. So -1. So we got -1. Okay, now we got to go D, negative B, negative C, A. And remember, this is A, B, C, D. Okay, so D is -1, -1. Negative B, B is 1, so -1. Negative C, or C is -4. And finally A, and A is just 5. So -1, -1, 4, 5. -1, -1, 4, 5. Now we multiply the -1 through. Scalar multiplication here. 1, 1, -4, -5. So it just changes all those. Okay, there's our A inverse. There's our A inverse. So step 2 is I say, well, remember I was originally given this, and we ran the A inverse on it, right? So X is A inverse B. So matrix X is A inverse, which is, we just found that, 1, 1, -4, -5, times matrix B. Let's go back up here and look at matrix B. 11, 13, -9, -10. 11, 13, -9, -10. And now I just do matrix multiplication here. So I'm going to go first. So 1 times 11, 11, this is row 1, column 1, plus 1 times that -9, -9. Now I'm going to go first row, second column. So 1 times 13, 13, plus 1 times -10, -10. Okay, now let me go second row, first column, so -4 times 11, -44, plus -5 times -9, that's 45. And finally, lastly, let me go second row, second column, -4 times 13, oh, what is that? That's 52, -52, plus -5 times -10, looks like we got a 50 here. So matrix X ends up being 11 minus 9, 2, 3, 1, negative 2. Okay, so 2, 3, 1, negative 2. And that is matrix X. Let me go back and we'll look at what does this mean? Well, originally, right here, the question was matrix A times what gives me matrix B? And we just found this what? We just found that matrix X, what that required of us. Okay? All right, let's do another one here. We got a matrix A, matrix X equals matrix B. First thing we have to do, we're going to have to find A inverse, because A inverse A is 1x. So now we got to say, what's A inverse? Then we'll multiply by B. Again, this is A, this is X, this is B. Okay? All right, so step one, find A inverse. Step one, A inverse 1 over the determinant of A. The determinant of A times D, negative B, negative C, A. Okay? So 1 over the determinant of A. So that's 15. 1 over 15 minus 14. And then we got D, 5, negative B, negative C, and A. So we got 1 over 1. So just a 1 in front. That's not going to change anything. 5, 2, 7, 3. So 5, 2, 7, 3. That's our A inverse after we multiply the 1 through. Okay. Step 2. Now we say, well, X is A inverse B. 5, 2, 7, 3. Multiply by matrix B, which I don't recall. 1, 1, negative 2, negative 2. And we get 5 plus negative 4. Now we go 5 plus negative 4. 5 plus negative 4 again. I'm going to go here. 7 plus negative 6. Finally, 7 plus negative 6. This ends up being 1, 1, 1, 1. How about that? That's matrix X. 1, 1, 1, 1. Okay. Now, lastly, actually for inverses, we'll get into it on the next video, but for solving a matrix equation, we are done. Find A inverse multiplied by matrix B. Make sure you guys bring your questions.